This is the Chesapeake Bay, a giant tongue of water reaching from the Atlantic Ocean inland past Virginia, Washington, D.C., Baltimore, and up to the Pennsylvania border. When he first saw the Chesapeake Bay in 1608, Captain John Smith wrote, "Heaven and earth never agreed better to frame a place for man's habitation." And the bay has indeed proved a most desirable habitation. 12 million people now live on or near the bay. But this is also the Chesapeake Bay, a place man has inhabited carelessly. Within the last generation, the water has become murky, and once bountiful seafood populations, fish, oysters, and crabs, have dwindled. But before policymakers can frame laws to clean up the Chesapeake Bay, they need solid information on the bay's health from scientists and statisticians. This team from Versar Incorporated, an environmental laboratory, is taking the bay's pulse by studying the bay's mud. It's here that the impact of man's use and abuse is recorded most accurately. The life in the mud, the clams, worms, and other organisms, is called the benthos.
Without the benthos, there would not be the food for the crabs and the fish to feed upon. From a monitoring tool point of view, they have characteristics like they're not mobile, they sit still, they're easy to sample. We know how the environment affects their distributional patterns.
The back-breaking work of monitoring begins before sunrise. 5 days a month, 10 months a year, biologists take mud from 70 different locations, picked using a statistically sound sampling plan.
The Chesapeake Bay is such a dynamic system that what's occurring in one area of the bay would be quite different than what's occurring in another.
Then back to Versar's lab, where workers label and count every organism collected from every station in the bay. Hal Wilson leads the analysis to determine the relationship between abundance of organisms and human activity. But first, he simplifies the data collection with a regression equation.
It's very simple to measure a length or a width of an organism. Since we have a very good regression between weight and width, we can cut down our work by measuring the width and using this regression equation to predict the weight.
Even with weights and widths of all the organisms, Hal's task of correlating abundances and pollution is not an easy one.
Studies have the problem of trying to separate natural variation from man-induced variation, and seasonal variation is one very large component of it that you can't really separate out unless you have many years' worth of data. It's possible in some deep areas of the bay during the summer to have oxygen drop below critical limits and to sometimes go to zero. And that condition poses an incredible stress to aquatic organisms. As a result, we measure the dissolved oxygen concentration of water because it's a very important explanatory variable to understand distributions and to understand the kinds of natural stresses that these organisms are responding to.
Man makes his own contributions to the dissolved oxygen problem. Sewage treatment plant effluent and farm runoff also choke off the bay's oxygen supply.
In any estuary, the whole thing is not sick or the whole thing is not well. Different places have different kinds of problems. And in the deep central region of the bay, like what you see out behind me here, the anoxia, or the low dissolved oxygen, appears to be getting worse over time.
The dissolved oxygen trend was only apparent with statistical analysis that smoothed out seasonal variation.
Because there is such a seasonal fluctuation in bottom dissolved oxygen, it would be difficult to ascertain if there was any trend in dissolved oxygen over this time because of the seasonal signal is confounding that trend. This is the trend in summertime bottom dissolved oxygen. The line seems to be going down significantly.
Because of this very graphic statistical analysis, lawmakers in states bordering the bay took action. They committed themselves to a 40% reduction in pollution from farm runoff and sewage treatment plants by the year 2000.
You're trying to understand what's happening over the long term, and you're trying to understand it for a purpose, and that purpose is, one, to provide a perspective for what you see in the short term, and two, to help you manage the resource better or more wisely.
many things are being done here that haven't been done elsewhere, and so I feel there's some real importance to the work that's being done on Chesapeake Bay. That offers a lot of motivation to keep going and to look at the data, to do the analyses and really think about what we're getting.